A projectile is fired at an angle theta equal to 60 degrees. It is fired with an initial velocity of v0 and it goes on to strike the top of a tower of height h. The angle with which it strikes the tower is 30 degrees below the horizontal as shown. We are given that the angle of launch is 60 degrees and we are given that the angle at which it strikes the tower is 30 degrees. But we are not given how far the tower is from the launch point. We are asked to find the relationship between the initial velocity v0 and the height of the tower h for this to happen. One concept we could use here is that the component of velocity in the horizontal direction does not change as there is no acceleration in the horizontal direction. So v0x would equal to vx. v0x at the launch point would be v0 times cos of theta or v0 times cos of 60. And vx at the landing point would be v cos of 30, where v is the velocity of the projectile at the time of landing. With this we get the relationship between v and v0. And v equals v0 over the square root of 3, and this is our first equation. The height of the tower is given to us as h. Let's apply the third equation of motion along the y-axis. We have vy squared equals v0y squared minus 2gh, and think in terms of only the y-axis. Vy, the final velocity along the y-axis, is v sine 30 pointing downwards or in the negative y direction. But that will not make a difference since this formula uses the square of the velocity. v0y is the initial velocity along the y direction, and that is v0 sine of theta or v0 sine of 60. And g is 10, and we have a minus sign here as the acceleration is in the negative y direction. Plugging in these values and also substituting for v in terms of v0 from equation 1, we obtain this equation linking v0 with the height h. Now let's simplify this equation. Simplifying, we obtain v0 as the square root of 3gh. For this relationship between v0 and h, if we launch a projectile at 60 degrees, then it would land at 30 degrees on a tower of height h, whose topmost point lies on the projectile's trajectory